This is Haoyu Wang, and here's homework 6 of class EL6303 class. And here is the homework 1. We are given a density function at x, y equal to a times 1 plus xy, x times y, while x and the absolute value of x is smaller than y, absolute value of y smaller than 1. And smaller than 1, I mean both smaller than 1, and is equal to 0 in otherwise cases. So first of all, we need to find out the letter A. So the density function above defined is joint density function. So what we usually do is make the equation equal to 1 and do integral 2 times for x and dx and dy. Then we can get 4 times a equal to 1. A is equal to 1 over 4. And for the second question, we need to know are x and y uncorrelated, and the short answer. So for the expectation of x, we do basically the same things. Use the equation. You use the formula to the integral 1 from 1 to -1, integral from 1 to -1. 1 over 4 is a. So a is 1 over 4. So a times x times 1 plus x times y. Dx dy equal to, then after I do the calculation, a equal to 0. For the expectation of y, we also do the same things, but here is different. A times y times 1 plus x times y dx dy, which is also equal to 0. And for the expectation of x and y, we do the integral 1 from 1 to -1, integral 1 to -1, a times x times y times 1 plus x times y dx dy, which is it's a times 4 over 9. A times 4 over 9 is equal to 1 over 9. Thus we can tell ex times ey is not equal to ex and y, so which means they are not correlated. For the third questions, we can get are x and y independent? For the third questions, is also very simple. We know fx of x times fx of y equal to 1 over 4 because fx of x is 1 over 2, fy of y equal to 1 over 2. So times this together is 1 over 4. But for the antifunction x and y, we can get this. The answer is 1 over 4 times 1 plus x and y, x times y. So which means this cannot be 1 over 4. The answer cannot be 1 over 4. So they are not independent. For the fourth questions, we need to find out the joint density function of x squared and y squared. So make the question much more easier. We choose to make x squared equal to z and y squared equal to w, and then we can get j equal to 2x 0 0 2x, and we can draw the figure here. So it's all in the shadow part. Then we divided the area into 4 parts, 1 2 3 4, and for each part we can get x equal to square root of z, y equal to square root of w because it's here. So for the second one, it's negative square root of z, y is equal to square root of w because it's here. And we do the same, x equal to negative square root of z, y equal to negative square root of w because it's in part 3, and part 4 is x equal to positive x square root of z, y equal to negative square root of y. And we need to find the density function of z and w. So we add each part together. We can get here and the negative square root of z plus negative square root of w, negative square root of z, positive square root of w. We add these four parts together. We can get here 1 over 4 times square root of z times w, which result the density function of the density function of zw is equal to the density function of x squared times x squared y squared. So we can get it here. Since there's a square root here, so it has to be positive, so I added the absolute value here. And this is the density function of x squared and y squared. And for the fifth question, provide or disprove that x squared and y squared are independent. So since we have the density function of zw equal to 1 over 4 z negative 1 over 4 z to the negative 0.5 times w to the negative 0.5. For fz of z, we do the integral from 1 to 0 dw. We can get the answer is 1 over 2 times z to the negative 1 over 2. For the fw of w, we do the same things, the integral 1 to 0 and 1 over 4 times z to the negative 0.5 times y to the negative w to the negative 0.5 dz. We can get the answer is 1 over 2 times w to the negative 1 over 2. Then we can get we just type this together, fz times fw equal to fw and z. So we know z is x squared and y is w is y squared. So these two are the same. Just plug these two back into the equation. We can get the answer is they are independent.